Alright, so before we get started, the homework grades are in from last week. For a few of you that did it. We're basically down to 2 weeks of instruction. We have this week, then we go to Turkey for a week, and then when you come back, there'll be one more week of instruction. And then it's already kind of the finals. We'll have like a week of finals review, and then a week of finals. So, it looks the way it's looking, especially if you guys can participate and help us get through this lesson, that we will be going over the test five, the one we took last week. We'll be going over that tomorrow. And why is that even extra important? Because the performance finals on Thursday is going to be entirely based around test five. So I'm going to use that review of test five to be kind of like the review for the performance finals. That's ground facts. Okay, any questions on any of the stuff I just said? Um, so today we move on to compound probability. What is the word? And actually we did a little bit of, we got a little bit of a taste of this. We did like two-way tables and stuff, but it goes a little bit more beyond this. What does the word compound mean? Something gets compounded. Very good, yeah. So you get two or more things and you put them together. So when we talk about compound probability, we're getting two or more events, and we're calculating the probability of either both events happening or one of the two events happening. Now, I did my best to kind of sift through the notes when I made these to kind of separate them. So the main focus this week is going to be on or probability, which is one or the other. Okay, what did I tell you to associate with or probability last week? Or hey, what did I tell you to associate with or probability last week? Word association. What are you associating with? Okay, good. Adding is one of them. I'm surprised you come up with that. That's good. Yeah. When we're calculating word probability, you want to add. What else? What word did I tell you to associate with the word probability? Home, ladies, is that every word association with word probability starts with you and ends with you. Yeah, union. So when you're calculating the probability of a union, you're doing or probability. So now there's two main types of or probability: mutually exclusive and not mutually exclusive. Um, Not that every single problem is gonna be this way, but like the classic problem to illustrate or probability deals with playing cards. You're gonna see examples that have playing cards. Okay, so like for instance, let's say they ask you, hey, what's the probability of getting a king or a queen? Well, those two events are mutually exclusive because there is no intersection. It is impossible for both to occur. There's no card that has a king queen on it. Okay? But now they were to say like, hey, what's the probability of getting a king or a red card? Well, now those are not mutually exclusive because there are some kings that have that are red. There's two of them actually, the diamond and the heart. So you're gonna see some of those problems here today when we do examples. So when you look at most like standardized tests, if it happens to have a reference sheet, even though you see two different formulas, the one that they normally put is just this one here. Because this is universal. How do you calculate or probability? You add. But if there is an intersection, there always doesn't have to be, but if there is an intersection, then you have to subtract that at the end. Does anybody remember the reason I told you why you have to subtract the intersection at the end? What we last week? Come on, guys. I know it's hard basically holding class with three people, but I mean, let's turn this into a good thing. You know, it's almost like having your own personal tutor, right? Very small numbers, more of my attention, but and you need to contribute. You guys don't remember last week when I told you why you have to subtract the end? I mean to remember. Because when you have an intersection, that intersection is part of both events. And we're talking about cars, right? With the king and the red. When I add, see, like, when I add the king plus the red, well, the red kings are being added twice. It's being included on both lists, but they only occur once. So you compensate that at the end by subtracting the intersection because you've already counted those twice. You're only supposed to count once. That makes sense. Jump into the notes. Alright. We saw this last week, a Venn diagram. Now this is a little bit different because it has three circles that are overlapping. But when they ask you, like they're only going to ask you about two at a time, so we can ignore that third circle when they ask you each one. So now none of these here say probability, though. They're not asking you to calculate probability. Well, I guess up here it does say probability, but over here it's just saying find Zaxby's intersection McDonald's. I don't see anything that's saying that I have to calculate the probability. You know, that'll have a P with a parenthesis. So let's just assume that they want us to find the tally, the count. What does that little upside down U stand for? Literally on the page. You should know it from last week, but what does that upside down U stand for? It's intersection. So let's give me a count. Give me a tally. How many, these are kids in a classroom and they're asked where they've gone to eat over the last month. So how many kids have both, the intersection, gone to Zaxby's and McDonald's? No. Remember, ignore the other circle, good. Where does Zaxby's intersect with McDonald's? That's the overlap of those two. How many kids fall in there? Elements. How many elements are in there? Huh? 8. What does this represent? It represents the intersection of you would say it represents the students who have gone to both McDonald's and Zaxby's. Alright, how about Chick-fil-A? What does that stand for? Union, the union between Chick-fil-A and Zaxby's. Okay, so that's telling you, now anybody that went to Chick-fil-A or either one, if you remember like I gave you like a diagram and it showed you that when you're doing union, anything that's in either of those circles, you're adding those all together. So how many fall in there? 35, 50. I'm getting 56. 76? I found out 35 and 15 is 56. I'm getting 66. What does that represent? That represents kids that went to at least one of the two. Because they might have gone to both, but they went to at least one of the two. This next one is a nice one. I like it. Because you look at this union, and you're like, oh yeah, hey, the union of Chick-fil-A and McDonald's. Au contraire, mon frère. What's that little symbol mean on the outside, the little apostrophe? Huh? The complement. So what that's telling you is, all right, if this is the universal set, this is everybody, right? And you were to get union of Chick-fil-A and McDonald's, ¿te gusta McDonald's, Anixi? So what's everybody that falls out of Chick-fil-A and McDonald's? who does not fall inside that union, but that's still part of the universal set. Huh? No, not just 23. It would be 40. It's the 23 kids that only went to Zaxby's and the 17 that went nowhere. And what does that represent? It represents the kids that have not been to either Chick-fil-A or McDonald's, or being the key word for students. Tell whether the events are mutually, and this is weird, I don't know why they use these words, but let's change this to exclusive. In order to be mutually exclusive, it can't be an intersection. Exclusive means exclusive. Like it's not, they're completely separate. So, are any of these events that we've done, like, do these have an intersection? Yeah, they all do. Yeah, they all do. Look at all these in here. Everything that's in here has an intersection. So, yeah, are these mutually exclusive? No, they are not mutually exclusive. The way that they worded it about mutually inclusive, then I guess you would say yes, but I've never even heard that said. People call it mutually inclusive. Any questions? Any questions from home? Oh, Chris is here. Hey, Chris, somebody was asking about you. Ashley is here.
Chipotle boy?
Chipotle, yeah, he's here. He got Chipotle. We got a bowl today. Barbacoa. He's not saying anything though, so I think he just signs on. Consider the diagram below, which shows the names of the students in Miss Leary's class that own a bicycle or skateboard. Use only the first letter of the names for the subsets. Alright, so let's list sets within a set. Bicycle, intersection, skateboard. What names fall in the intersection of bicycle and skateboard? Esta montar bicicleta. I don't know if it's skateboard. Yeah, Joe, Mike, Linda, Rose. That's the intersection of the two. And they said just put the first letter. So Joe, Mike, Linda, Rose. How about bicycle, union, skateboard? Oh, but wait, there's more. Put this guy right there. What's that say? Oh, what does that mean? A little apostrophe. Complement. So who is not in this union? Yeah, Amy, Gabe, and Abby. And since Amy and Abby start with the same, I'm gonna put like A-M, comma, B, comma, A. Don't forget Amy. Not right skateboard. Alright, so give me the subset that are just skateboard. Who are people that ride skateboards? Yeah, you have to have everybody from the intersection from before Joe, Mike, Linda, Rose, but then also our friends Brett, Juan, and Toby. And then finally, the essence I haven't heard from you today, can you give me the complement of the bicycle subset? Who here does not own a bicycle? Yeah, Brett, Juan, Toby. Anybody else? Yes, sir. Yes, ma'am. Amy. Alright, now we're starting to get into probability, but this is still, like, we haven't really done anything new from last week. This is still a continuation of last week. So, Find the probability that a student owns a bicycle. So our sample space is students. That becomes our denominator. How many total students are there? ¿Cuántos estudiantes? How many of those have a bicycle? Nine, yeah, there's 9 in the bicycle. Tipo de bicicleta, hay 9 nombres. Now, I wish this would tell you how to express the answer. It doesn't, so I'll just do them in every method. As a fraction, this could be reduced. So if they were to tell you to leave it as a fraction, it would be 3 over 5. So you divide by 3. As a decimal, you wouldn't need to go to 4 decimal places because this is 0.6 exactly. And then, Emilsi, ¿cómo se escribe punto 6 como 1%? Christian, are you there? Are you eating? Yeah, absolutely. Or how do you write 0.6 as a percent? Not 6%. 60%. Over 1, 2, right? 60%. Find the probability that a student owns a skateboard. Alright, so it's still probability. Our sample space is still students. How many kids have a skateboard? 7. Now this one can't be reduced, so if you were asked for a fraction, you would leave it. I'm getting as a decimal, I mean, you gotta see how many decimal places they would tell you, but I'm gonna assume 4. So 0.4667. And then that would give me as a percent approximately 47%. Find the probability that a student owns a bicycle or a skateboard. So we're still just looking at all students. Now, or implies a union. So how many are in the union of bicycle and skateboard? Bicicleta and skateboardo. Well, there are 12 names inside either one. It gives me 4 out of 5 if I reduce, which as a decimal is 0.8. I was gonna ask Chris, but I think Chris already knows, so I'll just ask 0.8. I mean, as a percentage. And let's find the probability that a student owns a bicycle and a skateboard. Notice how it says and, so that's the intersection. So there's still a total of 15 students. How many names are in the intersection? 4. Okay, this one can't be reduced. So we can just divide to get a decimal. And that gives me 0.2667. Which is 77%. Find the probability that a student does not own a bicycle or a skateboard. So that's the probability. I got cut off there because the complement sign right here. So we're still talking about students. How many own neither? No bicycle, no skateboard. How many do not fall in the union? 3, good. So that's 1 out of 5. As a decimal, that's 0.2. Y como 1%, ¿Y cómo se escribe como un por ciento? Muy difícil. Any questions at home? Chris, any questions for you? Mild or medium, Chris? Alright, let's ignore this one, this first one, because this first one here is more for and it was confusing today, so let's just ignore that one and jump to the second one. Notice how they're starting to show you that word probability is the card, deck of playing cards that you draw. What is the probability of rolling a die once and rolling a 2 or an even number? Okay, so here's or probability, so we know we're gonna add, as what he said. Let's look at the first event. What's the probability of rolling a 2 on a die? No. How many faces of the die have a 2 on it? 1 out of how many faces in total? Plus, let's look at the second event, even number. How many even numbers are on a die? 3, 2, 4, 6. There's 3 of them. You guys know what a die is, right? A little. 1, I don't know how. Like 4 is 3. But then the question is there an intersection of the two? Are there any even numbers on the die that are 2? Is there a face that is both 2 and an even number on a die? I know it's kind of weird. It sounds overly simplistic, but yes, 2 is an even number. So guess what? At the end, because there is an intersection, because 2 is an even number, you have to subtract that intersection. So after these two cancel out, and you end up with 3 over 6, which is just 1/2. That's the decimal is 0.5. And Mixi, 0.5 como 1%. Dale. 50%. Okay, good. No questions there. I want to make it through 4 more slides today. What is the probability of randomly selecting a card from a standard deck and it being a red card or an ace? Yeah, here we go with the deck of cards. A red card or an ace. How many cards are in a deck of playing cards? I'm surprised how few kids know this. 52. Look at one. 52. Very good. And out of those 52, how many are red? Crazy. 23? No, half of it. Half of it is 26. Half are red and half are black. Plus, because of 4, how many aces are there in a deck? ¿Cuántos aces hay? Maybe. How many aces are there? Yeah, it's 4. Okay. But now we have to think, are these events mutually exclusive? Is there an intersection? Are there any red aces? Yeah, how many aces are red for it? 2. Yeah, there's 2. The heart and the diamond. And think about it. Here's the reason why. Okay? Those red aces were counted in this group, but they were also counted here. You're double dipping with them, and you can't do that. That's why we have to subtract at the end. So 26 plus 4 minus 2 is 28 out of 52. That can be reduced. This one also doesn't tell us which form to put it in, so we'll just put it in on all three forms. 28 over 52 can be reduced by 4. Jorge says 7 over 13, and we agree with Jorge. As the decimal, let's just say it's going to 4 decimal places. I'm getting 0.5385. And mil sí, por ciento. Sí, sabes, how much percent? Thanks. Approximately 54. What is the probability of randomly selecting a card from the standard deck and it being a red card or a club? So again, we see or probability. That indicates a union. So we're going to add. Jeanette, red card. What's the probability of a red card? Second column in a row. Red card. Good. Now some of you may be asking yourself, well, but Mr. Romero, isn't that just 1/2? Because hey, half the cards are red and half the cards are black. Yes, but because or probability involves adding and with fractions, you need to have the same denominator. I actually prefer to just leave it with 52. And you can reduce afterwards. So a red card or a club. Ooh, yeah, this one might be hard for you. You guys know how many cards have a club? Out of the 52? 13, good, go ahead. Oh, the thing you answered. But now here's $1 million question. Is there an intersection? Because if there's an intersection, you have to subtract it. So is it possible for a card to both be red and have a club on it? Heck no. Nope. Yeah, all clubs have to be black. Yep. Yeah. So we got 39 out of 52. That actually can reduce to 3 out of 4. As a decimal, this is exactly 0.75. Sí, por ciento, ¿cuánto? Any questions so far? Okay. Two-way tables, we saw these last week. As a convenience, I have added the marginal frequencies for you so that you don't have to add them up in the calculator. So let's see, this is more kind of a review from last week. What is the probability that a randomly selected person, so that means that our sample space is going to be here, 44, does not have a job, or, okay, there's that or word, or is 18 years old or greater. Okay, so let's look at the first event. Esme, what is the probability of getting somebody that does not have a job? How many people do not have jobs? No, yeah, no, yeah, no, yeah. Apology accepted. How about the second event, Jorge? 18 years old or greater. How many people are 18 years old or greater? 679 plus 944, but then you have to consider, look, are these mutually exclusive or not? Is there an intersection? If there's no intersection, then you just add. But if there is an intersection, you have to subtract it. Are there people who are both, who fit in both categories, who do not have a job and are also 18 years old or greater? Yeah, they're here. It's literally two-way table. It's literally where they intersect. It's 92. So those 92 people are being counted twice. It's not fair. Minus 92 out of calculate plus 679 plus, no, sorry, minus 92. I'm getting 924. Mohammed is not here today to verify on this calculator. I'm going to have to rely on you. This should be able to be reduced to the both even. I'm getting 231. If the question asks you to leave it as a fraction, we'll put 231 over 236. If it asks it for you as a decimal, depending on how many decimal places they would ask you to go around to, I just do 4 as a standard here. I'm getting 97.88. Emilsi, por ciento. Tampoco. Todavía no sabes, por ciento. 98%. So you have a 98% chance. It's almost a virtual certainty that if you randomly pick someone, that they will either, one or the other, either not have a job or be greater than be 18 or greater. The only people that we're not considering are these 20 here. These are the only 20 that don't fit into one of those two categories. What is the probability that a randomly selected person either has a job or does not have a job? And yes, it seems pretty obvious, but let's just go through the ritual anyways. Because if you think about it in real life, you can ask anybody, they either have a job or they don't have a job. But let's just do it by the numbers. Jeanette, give me the ratio for people that have a job. Us. Emil, sí. ¿Cuál es el porciento de los que no trabajan? Very good. Do not have a job. And if you have to look at the table, I mean, look at it, but the point is, look, has a job, does not have a, there's no intersection between the two. Common sense. You can't have a job and not have a job at the same time. That doesn't make sense. So these are mutually exclusive. There is no intersection. But it's pretty obvious that when you add them up, you're going to get 1. You have it, that number works as a fraction and as a decimal. So as a percent, you have a 100% virtual, not virtual, it is 100% certain that if you randomly pick a person, they will either have a job or not have a job. Questions? Hey, Chris. Still not there? Hey, you made it back now. Oh, man, we were worried about you. You didn't hear us asking about you before? You did hear, you just switched to be quiet. Oh, well, it's good that you're back now, so I'm not going to call you too. For each pair of events, tell whether the events are mutually exclusive or inclusive, overlapping. Find A or B. Okay, well, we can just talk about the first part, but let's write down the compound probability. What is the probability of randomly selecting a card from a standard 52 card deck and having the card be a heart or a spade? So it's going to be something over 52 plus something over 52, and we'll decide afterwards if there's an intersection or not. Or hey, how many hearts in a, if you were surprisingly new, how many are in each two? 13, good. How many spades? Also 13. Are there any heart spades? No, there's no intersection here. So these are mutually exclusive. It's 26 out of 52, which gives you 1 heart. So 0.5 as a decimal. Easy, por ciento. Yeah, there you go. Anybody at home questions? All right, Chris, it's your moment now. Now you got it warmed up. So here we go. We're looking for a black card or a face card, and we know it's going to be out of 52. Chris, how many black cards are there in a standard deck of playing cards? How many black cards are there in a 52 card deck? Very good. And how about face cards? They help you out here. Face cards are jacks, queens, and kings. How many jacks, queens, and kings? And there's 4 suits, 3 face cards per suit. How many?
I just want one.
Oh, close, man. Are you in the car again today? Yes, ma'am. No. There's 4 suits and 3 of each. What's 3 times 4? Face card. Okay. No, it's 12. Well, then now you're gonna be a card shark at the end of this lesson. But then we have to ask ourselves: are these events mutually exclusive? Are there black face cards? Yes, there are. How many face cards are in black? Yeah, half the 12, sure, 6. Yeah. So that ends up being 32 out of 52. 8 out of 13. 0.6154. And that is Emilci. ¿Cuánto por ciento? Si me lo dices, te paro de preguntar. Overall, that's me. 52. Oh dear. I think you were close though. 5 rounds ago. What is the probability of randomly selecting a card from the standard 52 card deck and having the card be an even numbered card or a red card? So there's that magic forward. So over 52 plus over 52. Let's be a tricky one. I don't know if that means plays cards every day, but let's see how many even numbered cards are there in the entire deck. Even numbers are 2, 4, 6, 8, 10. ¿Cuántos números pares? 2, 4, 6, 8. Who do we appreciate? Not Irma. Not Irma. No, not Irma. Plus, how many red cards? 26. But is there an overlap? Can there be even numbered red cards? Yeah, half of the red cards, half of those 20 are even numbered. So we get 36 out of 52, which can be reduced. 9 out of 13. And then we divide, they give me 0.6923, 0.6923. Crystal giggle at 69%. What is the probability of randomly selecting a card from a standard 52 card deck and having the card be a heart with a number on it or a spade? So here's your or. How about a heart with a number on it? How many hearts have numbers on it? ¿Cuántos corazones tienen números? 2, 3, 4, 5, 6, 7, 8, 9, 10. 9. How many spade face cards are there? How many spade cards have a face on it? I think that's me. You gotta start playing questions today. Is there an intersection? Are there any spade face cards that also have a heart and a number on it? No way, Jose. There's not even any spade hearts. There's no numbers and faces. There is absolutely no intersection here. So all I gotta do is add. All right, I'm just trying to finish, but then we're not gonna finish. We're just having too much fun here. So that's 0.2307, 0.2308. ¿Sí? 23%. No quiero más. No me gustan los lunes. Alright, this will be the last slide here of day. What is the probability that a randomly selected person has a job? So this is going to be the same as we had on the one before. Was it so 944 was the total. So randomly selected person has a job. Okay, so this simple probability. Look, and they do say nearest percent. Let's treat this whole page as just percents. So how many people have a job? 607? 607 out of 944, which to the nearest percent is 64%. Let's just pretend that this direction is applied to all of these. What is the probability that a randomly selected person is less than 18 or does not have a job? Okay, so we're gonna have to add out of 944 plus out of 944. How many people are less than 18? I'm getting 265. There's 265 that are less than 18 or does not have a job. 245, 337. But then the question is, are there people that are 18 that do not have a job? Yeah, this is an exception here. I gotta take away those 245 because they're being counted twice. Very, very lucky. Okay, and then they were 20 as a percent, so we just put 265 plus 337 minus 245 divided by 944. Is approximately 38%. What is the probability that a randomly selected person is less than 18 or has a job? So out of 944 plus out of 944 is less than 18, that was 265. Has a job is 607, but then you gotta take away the intersection of both, which is just 20. 265 plus 607 minus 20 is 852 divided by 944. I'm getting about 90%. Anybody have any questions for me? Alright, we'll stop right there. We'll continue tomorrow, and tomorrow we'll also go over the test, so make sure you're here.